Today we will investigate the use of top-down and bottom-up reasoning and visualization as it applies to big data. First, a little terminology. Top-down, or deductive reasoning, starts with a high-level view and then breaks that high-level view down into components, each of which is essentially a black box. Then, one breaks down each of the black box components into its subcomponents, each of which is itself a black box. This process is repeated until the necessary level of granularity for each component is achieved. Bottom-up or inductive reasoning starts with low-level components, and then it connects those components in a way that builds a bigger component. Then it connects the bigger components into even bigger components. And then it repeats this process until the necessary level of functionality or reasoning has been achieved. For this past week's research, we used the Carnegie Mellon Apollo project to review the connections between scholarly works provided by the Google Scholar project. The Apollo tool provides excellent insight into the value of and challenges related to top-down and bottom-up reasoning and visualization. Apollo allows one to traverse the links created by a graph representing scholarly citations, and it allows for high-level grouping. So an Apollo project file containing high-level groups is a top-down style view of big data. However, when looking at individual data points, it is essentially presenting a bottom-up style view. In fact, the Apollo authors intended their tool as a bottom-up visualization and tool according to the research paper that we read. However, once groups have been created using the tool, it's top-down. What really strikes me as the important lesson from the project, and perhaps one of the most important lessons from this entire course, is the need to connect top-down reasoning and bottom-up reasoning, and of course, visualization. In plainer English, this means balancing the big picture and the details, not losing sight of the forest for the trees, and at the same time recognizing the nuances within the details. To be an effective thinker, one must be effective at both types of reasoning. To be an effective visualization of big data, an interface must be effective at both types of visualization.